All right, in this lecture we're going to solve quadratic equations by factoring. So we're finally learning a new method to solving equations. So a quadratic equation generally in standard form basically has all the terms on one side and then it's set equal to 0. So a general quadratic formula or quadratic equation in standard form would look like this: a x squared plus bx plus c. So that's a second degree trinomial. The a, b, and c just represents coefficients and a constant, and that's equal to 0. So what we're going to do is solve these. Now, the problem is we can't solve these like a linear equation in first degree. We can't isolate the variable term because we can't combine x squared and x terms. So we want to solve using the zero factor property. And before we do that, I just want to talk about this equation down here. So consider solving x minus 2 times x plus 3 equals 0. And notice this is a factoring. We basically have two factors multiplied together equaling 0. And so the only way that can happen, if we have, say, just a multiplication, a times b equals 0. Well, the only way I can multiply two numbers to get 0 is if one or the other factors is 0. So if you think of multiplication, the only time I can get 0 for an answer when I multiply is if one or the other factor is 0. And we're going to use that idea to solve these types of problems. So if you think, we have a situation where we have an a times b equaling 0. We have two factors. So the zero factor property basically says if we take the first factor of x minus 2, if that factor is equal to 0, then the product will be equal to 0. Or the other factor, x plus 3, equals 0. So if one of these other factors is equal to 0, then we know the product has to be equal to 0. So now we can just go ahead and solve each one of these. So if I add 2 to both sides, I get x equals 2. Or subtracting 3 from both sides or attaching a negative 3, we get x equals negative 3. So we actually end up with two answers because we have the two factors and each factor could be equal to 0. So this is called the zero factor property. And notice if we have a perfect situation where we have two factors equaling 0, which we have here, then we can solve it by just setting each factor equal to 0, and that's the zero factor property. So I want us to realize that if we were to expand this, if we multiply these two binomials, we would end up with x squared. The middle term would be plus x, and then minus 6 equals 0. So if we took and expanded, what we actually did is we solved a quadratic equation. So if we expand it, we have a quadratic equation, a second degree equation. So a lot of times that's how we'll explain these, is second degree equations. So that means the highest degree term is squared and so on. So I want to use this strategy to solve quadratic equations. So again, I'm just going to move down and let's solve x squared plus 5x plus 6 equals 0. So the first step in solving quadratics is to make sure it's written in standard form. And that's, so we're going to write in standard form, which is that ax squared plus bx plus c equals 0. All right, so this one is already in standard form. It's expanded on the left side and it's equal to 0. So the next step we're going to do is factor. So we're going to take the left side here and factor it into two binomials. So again, when we factor, the first term gives us x times x, and then we look at the last term, factors of 6 that add to 5. So plus 2 plus 3. So now we have two factors equaling 0. So the next thing we're going to do is apply that 0 factor property. Which basically says if I have a product of two of factors equaling 0, then one of the factors has to be equal to 0. So x plus 2 has to equal 0, or the other factor, x plus 3, must equal 0. So the last step is just solve each, right, equation. So to solve the first one, subtract 2 from both sides, we get x equals negative 2, or subtracting 3 from both sides here, or attaching a negative 3, we get x equals negative 3. Okay, so let's try that on these next few problems. I'll just leave it here for now. We want to solve 5x squared equals 25x. So this is second degree. So the first thing we want to do is write in standard form. So you notice the terms are on both sides. So I'm going to subtract a 25x on both sides, and I end up with a 5x squared minus 25x equaling 0. So now it's in standard form. So we'll factor the left side. Well, there's a greatest common factor of 5x, and I'm left with an x minus 5. So that's equaling 0. So now once it's factored, I'm going to apply the 0 factor property. So I'm just going to bring that up over here and set each factor equal to 0. So the factors are 5x and then this x minus 5. So 5x has to equal 0, or x minus 5 has to equal 0. So solving, dividing both sides here by 5, I notice I just get x equals 5, or x equals 0. Or if we add 5 to both sides, we're getting x equaling 5. All right, so let's apply the same strategy for the next two. Solve the quadratic equations by factoring. Again, we know these are quadratic equations. We have a second degree term here. So first thing we want to do is write in standard form. Whoops, sorry about that. So we want to write in standard form. So here I'm going to add 10x to both sides. And in standard form we would have 3x squared plus 10x minus 8 equals 0. So after we write it in standard form, we want to factor the left side. So the factors have to start with 3x and x. The second terms would be plus 4 and negative 2. So if you check the middle term, I get negative 2x, and 3x is 12x. I do get the 10x. So here's my two factors equaling 0. So now I'm going to apply the 0 factor property. and set each one 3x minus 2 equals 0 or x plus 4 equals 0. So if I solve the first one, I get 3x equals 2 or x equals 2/3. Or if I solve the next one, subtract 4 from both sides, x equals -4. Okay, and then finally the last one, you notice this starts out as x times the quantity 4x plus 12 equals 9. So the first thing I need to do is expand to write in standard form. So if I expand the left side, multiplying through, I get 4x squared plus 12x equals 9, or excuse me, equals -9. And then if I add 9 to both sides, I get the 4x squared plus 12x plus 9 equals 0. So it's in standard form, so now I want to factor. And when I look at this, I have a trinomial. The first term is a perfect square and the last term is a perfect square. So I'm going to try a binomial squared and see if this factors. So the first term would be 2x plus 3, the quantity squared. So it is a binomial squared. The middle term does check. So 2x times 3 is 6x, and then you double that to get the middle term. So that is the factorization. So to solve this, the zero factor property just says take 2x plus 3 is set equal to 0. Or the other factor, again, is a 2x plus 3 equaling 0. So that's redundant. If I solve this one, I get, if I subtract 3, I get 2x equals -3. Or x equals -3/2. I'll have to write that up here. So I get x equals -3/2. Well, of course, if I solve this one, I'm going to get the same answer. So what the answer is -3/2 for both. So a lot of times when we do this, we will say that x equals -3/2 repeated, and that'll make a little more sense later on. But for right now, it only has one answer because it was a binomial squared, and each binomial gives me the same answer. All right, so just review. To solve a quadratic by factoring, we're going to write in standard form. That might mean we have to expand and set it equal to 0. We'll factor the left side, we're factoring, and then applying the 0 factor property. Set each factor equal to 0 and solve.